Hello student, myself Digant Sakhewala, I am your science teacher. Today we will learn chapter number 10, gravitation. In this chapter we will learn about the universal gravitational constant capital G. We will learn about what is universal law of gravitation. Okay, so we will start our topic. Whenever we drop any object from any height, it is called free fall. So whenever we drop the object on the earth, then why it is going in the downward direction? This type of question first arises in the mind of Sir Isaac Newton. When he was sitting under the apple tree, at that time one apple fall on his head. Then he think that why this apple not go in the upward direction and why it goes in the downward direction. To get the answer, he find out that gravitational force is responsible for that apple is going in the downward direction. Okay. Free fall of an object indicate that there must be some force acting downward direction towards the earth. Okay. Sir Isaac Newton in 1642 to 1727 AD said that planet revolves around the sun. Free fall for that gravitational force is responsible. Why we can stand on the earth? Why the moon rotates around the earth? Why the earth rotates around the sun? Why all planets rotate around the sun? Why the sun rotates around the galactic center? For that, the answer is what? A gravitation force. For higher standard, maybe you will learn some other theory by the Einstein special theory of relativity, but for the lower standard, we will understand that gravitation force is responsible for that. Okay. Gravitation force. Any two bodies of the universe attract, possessing mass, attract each other. This force of attraction is called the gravitation force. Any body are there in the universe, they attract each other, and the attraction between the two objects is called the gravitation force. It is the example of weak force. Suppose I am standing here, my cooler is nearer to me, so there is the attraction force exists between me and cooler. So that is also the example of gravitation force. Okay. Gravitation force is a universal force. Universal law of gravitation. Dear student, you remember that every object of universe attract each other. The force of attraction between them or two bodies is proportional to the product of their mass and inversely proportional to the square of the distance between them. The direction of this force is along the line joining the center of the object. In simple word, we can say that if there are two bodies are there in universe, so the force exerted on both the object is directly proportional to mass of them and inversely proportional to the square of the distance between them. We consider this figure. In the two balls are there A and B, their center are C1 and C2. This ball A apply the force on B. Okay, this is the gravitation force. Okay, it is not in the motion, it is the gravitation force. A apply the force on B, same way B apply the force on A. That is equal in magnitude, but it is in opposite direction. So we are adding minus sign, equals to we are adding F. It means that there is a weak force exists between two objects. So mathematically, how we can write? The force exerted between two objects is directly proportional to mass of that object m1 and m2, and it is inversely proportional to the square of the distance between them. Dear student, we know that proportionality means it is not equals to. If you remove the proportionality, we have to write some constant. So we are going to remove the proportionality. So F equals to capital G into m1 m2 upon r square. Capital G is called the universal gravitational constant. Its value is 6.67 into 10 raised to minus 11 Newton into meter square divided by kilogram square, and it was discovered by the scientist Henry Cavendish. At any place in universe and at any time, the value of capital G found to be a constant for any two bodies. Now dear student, how we get Newton into meter square divided by kilogram square, that we try to understand. If I want to get the value of or the unit of capital G, then r square is multiplied with f, so f into r square, and m1 and m2 is going in the denominator. We know that f is Newton, r is meter, and square is also meter square, and kilogram into kilogram, that is kilogram square. So we get the unit of capital G equals to Newton into meter square divided by kilogram square. We will continue our topic with the free fall of acceleration due to gravity. Okay, we have very great scientist. His name was Galileo Galilei. Okay, on Pisa Tower he carried out one activity. He took two balls or two objects which are having different mass and dropped that object. You surprised to know that these two objects are going with the same acceleration and reach to the bottom with the same time. He carried out this experiment in Italy. So from that he concluded that if friction force is absent, then if you drop any two objects which are having different mass, they reach to the bottom of the earth at the same time. You can do also this activity. Take 1 rupee coin and 5 rupee coin. On the same height you take it. At bottom you keep the one plate, steel plate, and drop 1 rupee coin and 5 rupee coin. Both mass are different. When you dropped it, you've noticed it that they both are reach at the bottom with the same time. It indicates that gravitation acceleration is never depend on the mass or shape of the object. Okay, it is always constant for the particular planet. Like Earth, it is constant, then on other planet its value is constant. Okay, Galileo carried out many experiments regarding the freely falling bodies. Freely falling body does not depend upon the mass or shape of the object. He carried out this experiment in Italy at Pisa Tower. He told we have to avoid the friction force, acceleration due to the gravity. So now we are going to find the value of small g. Okay, that is called gravitation acceleration. Capital G is called the universal gravitation constant. So dear student, here we will use two things. First, the universal gravitation force, that is F equals to G m1 into m2 upon r square, and second we will use the Newton's second law, that is F equals to ma, and we will compare them, and by comparing we get the value of small g. Okay, now on earth whenever we drop any object, then there are two bodies are there. One is object and second is earth. Okay, so first is the mass of the object and second is what? A mass of the earth. So F equals to G m, small m, that is the mass of the object, and capital ME, that is the mass of the earth. Now whenever I drop the object, then attraction between the object and the earth take place. So the distance between them will be the center of the earth and the center of the object. So ultimately I have to calculate the distance between the object and the center of earth, means I can take the radius of earth. So instead of r square, the distance between two objects, I can also take here the radius of earth, r is square. Now according to Newton's law, we can write F equals to ma. Now whenever we drop the object, that object come in acceleration due to what? Gravitation force. And because of that reason, instead of a we are writing g, so we can write F equals to mg. In definition we can say that the acceleration produced in the body due to the gravitational force of the earth is known as acceleration due to the gravity. So F equals to mg, and the equation number 1 and 2 we will compare. So by comparing them we get here capital G small m into capital ME upon r square equals to mg. So m is cancelled. We can write small g equals to capital G into me upon re square. Dear student, you know that me is the mass of earth and re it is the radius of earth. So if you substitute this value, capital G value, we know that 6.67 into 10 raised to minus 11 Newton into meter square per kilogram square. Mass of the earth is 5.976 into 10 raised to 24 kg, and radius of the earth equals to 6.378 into 10 raised to 6 meter. If you substitute these all the value, then ultimately we get small g value 9.8 meter per second square. It is not exactly, but it is nearly equal. The value of g is different on the different planet because the small g, gravitational acceleration, is depend upon the radius of the planet. So small gp means gravitational acceleration on planet equals to capital G into mass of planet divided by the rp square. Rp is the radius of planet, mp is the mass of the planet. Okay.